Okay, here we've got someone installing electricity meters. We've got her time is X, and it is assumed to be normally distributed, and we have a mean, and we have a standard deviation. So without reading any further, we can set up the beginning of our solution. Okay, set up a normal distribution, state the mean, state the standard deviation, and we know we're going to need normal distribution pictures. Okay, all right, maybe we'll need 4 because maybe it's backwards. Let's have a look. What have we got to do? We've got to determine a probability. So we're finding probabilities in at least the first 2. So these are forwards. So it's just going to be one picture. So you set up your probability, so your normal distribution curve, draw the center line in, draw Z in as 0, and then put your actual mean in here and decide how to set this up so that we want the probability of being less than 60. So where would 60 go in relation to this bracketed value, and which side of 60 are you going to shade for P equal of X being less than 60? Having got that set up, okay, you need a Z-score. So you're going to use the formula for Z. So Z equals something minus something over something, put the values in and get a Z value. And then you're going to be using your normal CD function. You need a lower and an upper to put into that. Okay. Obviously, this Z value will be one of the two. If you need to go to the very end of the distribution, then use either plus or minus 9999999, and your calculator will tell you the answer for P. Okay, the probability you're finding. So that's A.E1. And for A.E2, we said that was forwards as well. So it's going to be another normal distribution curve, again with 0 in the middle, and state the mean. And now we need our X value now to be between 2 values. In fact, one of them we've had before. So 60 is being used again. We need to have 30 on this second diagram. So the second diagram is going to have 2 lines. I don't know whether they're above or below the mean. You need 2 Z values. One of them we've already got. So just get the other Z value for 30. So this time, when you do this, it's going to be, your value of standardizing is going to be 30. All right, get a second Z value. And once again, you're going to get a lower, and you're going to get an upper. And this time, you're not going to need to use any 9999s, I don't think. And you're going to get a value of P. All right. But then the next one, let's have a look at this. Part .E3. Now we've got to find the time. So what the answer is going to be a time, and such that this. So we're beginning with a probability. So this is where you need to do it backwards, because it's beginning with a probability. So you need to give yourself your menu of 4 pictures. So the picture is going to be one of these, and don't be lazy, do draw out the 4 pictures. If you draw them neatly, you can actually end up using the picture. If you draw them very scrappily, then you can actually then just choose the one you want. So draw your standard 4 pictures and set up the one you need. When you've got the one you need, you will be able to get a p-value to look up from the picture. But remember that your calculator likes the probability to be on the left. So if the probability that you've labeled initially is on the right, find out the probability on the other side. So quote a p-value, and then that gives you a z value from your calculator. So from your calculator in inverse normal mode, inverse normal because you're working backwards, you're going to get a z value. So once you know the z value, it's back to the z formula. So a z, which you now know, is quote the formula, something minus something over something, but put your z value in, and the thing you don't know this time, the thing we're trying to find, is a time, which is a value of x. So the x slot in this formula, okay, is going to be the one that is the unknown, so leave it as x, but solve this equation, and after a line or so you should have your value of x, and that is going to be the answer. Okay, so that was part A. Now in part B, we've now got someone who is installing gas meters in the new houses. His time is different. We've now got a y, and we've got a mean and a standard deviation for y. Okay, and we've got to explain that y is unlikely to be normally distributed. So, okay, so we definitely on part B don't say it twiddles a normal. So in part B, we've got a mu, and we've got a sigma, That's what we'll record those. Why might a normal distribution not apply? Well, it's to do with the percentage probabilities that are in your notes. But the one that I always suggest you look at is to consider values of mu plus or minus 2 sigma. Okay? Because if you look that up, you'll be able to say the percentage of values that should be more than mu plus 2 sigma, and the percentage that should be less than mu minus 2 sigma. And if you work out mu plus or minus 2 sigma using these values, then going up or down 2 sigma from the mean may lead to values that are simply not sensible. So if you get non-sensible values by looking at this, you comment on that and you say what percentage should be outside that range, and that should get you the marks. Okay, so that's B.E1. That's why it's not likely to be normal. B.E2, where is it? Okay, we've got to state why the mean of a random sample of 35 gas meter installations is likely to be approximately normally distributed. So there is a theorem. You need to name that theorem and explain why that applies. And then for the third one, we now have a y-bar probability. Now this is a re-entry point, okay? If you've forgotten all of the theory, all right, you can still work out probabilities from this distribution because we know that y-bar will be normally distributed. So if I leave space for 3, okay, y-bar will have a certain distribution which will be normal, okay? But the things I need to know what mu is. Okay, and I need to know what because it's a distribution of a mean. They've been really kind. How are we picking up on this? We've got the y-bar is the mean. We've got the symbol y-bar itself. Okay, and the whole business about asking us why this distribution can be used is making you aware that this is the mean distribution. Okay, so we need a standard error. So quote your formula for standard error. Okay, and you should have an n value. So where is n? Okay, well, we need to know how many things is in the sample. So where are we told that? We've got information about the number of installations there. So get your standard error, and we want the probability. So we want the probability that y is greater than 40, I think. There it is. So we're finding a probability. It's a forwards question. So just like with the early parts of this question, we've got an ordinary normal distribution picture with a z of 0 in the middle, with the mean in the middle. Okay, we're going to get a z value, but now when we get our z value, we need to use the version of the z formula that divides by the standard error instead of by sigma. So you'll get a z value, you'll have sketched it properly here, you'll know what you're going to need once you've got this z for your upper and your lower, though you'd better be doing it the other way around. Lower equals, upper equals, and you're going to get a probability out of that.